What's up, guys? We're going to be continuing Chapter 7 here, looking at Section 5. We're talking about rational exponents and radicals. No, I don't mean radical like Ninja Turtle. This is actually a math term. So the index, write this down, the index gives the degree of the root. For example, a cube root would have an index of 3. So here, I need you to copy down this little diagram. The index is going to be the little number here. If there is not a number there, then it is assumed to be the square root. In other words, an index of 2. The radical sign is this little check mark thing. The radicand is the A, and then the whole thing together we would call a radical. All right, so this whole thing is called a radical with that. So you want to make sure you copy down that diagram. Here it says if the nth root of A is a real number and m and n are positive integers, then a to the 1/nth equals this, where n becomes the root of the radical. So make sure you have that. And if there's a number other than 1, then you could either raise a directly to that and then find the nth root, or you could find the nth root of a and then raise the whole thing to m. They are all equal to each other. It doesn't matter which way you go with that. You definitely want to have this entire slide copied down. Here's how I feel sometimes when I come back to school, especially after long weekends. I don't want a taco about it. That is the saddest thing I have ever seen. Okay, so what is the simplified form of each expression? There's a few ways to do this. First way and quickest way is to put it in your calculator. I'm not going to go over that on here, but if you would like to know how to put it in your calculator, just make sure you ask me while we're in class. The other way, or another way to do this, is to find the prime factorization of this. Okay, so the prime factorization is where you do that factor tree. And so this right here is 5 cubed, because 5 comes out. That's the prime factorization. Now, I want to know what number times itself 3 times equals 125. Well, the prime factorization tells me right here that 5 times 5 times 5 equals 125. So using the prime factorization, I could find that that equals 5. This right here, I could do something very similar. Let's go ahead and find the prime factorization of that. So the prime factorization of this one is 2 to the 4th. And I'm looking for a number that when is a factor 4 times equals 16. Well, that's a factor 4 times. So the 4th root of 16 is going to be 2. That's all you're really doing on that. So let's take a look at a couple examples for you. The answer will be up in 3, 2, 1. All right, so here's what I got. For this one, I got 3, and this one I got 2. Be careful, just because all the answers that I've done so far have been prime numbers, it doesn't always have to be the case. In other words, like the cubic root of 64 is not a prime number. So I would have 64 would be like 4, and then 16, and I could divide that down into 2 and 8, and this into 2 and 2, and this into 2 and 4, and that into 2 and 2. And so the prime factorization of this is going to be 1, 2, 3, 4, 5, 6 of these, 2 to the 6. I'm looking for a cube, so I need to take half of this, and then that means square it. So in other words, I'm going to take 2 squared, and then find the cubic root of that. That makes sense. Remember those rules from that last section. So the cubic root of this is going to be 2 squared. Well, 2 squared is equal to 4. All right, so be careful with these. Don't just assume it's going to be a prime number. Oh, hold on. I need to erase this. There we go. So using what we have on that first slide, we're going to write this first one. Notice that this 2/3 only goes to the A, so be careful with that. So that 12 stays along. This becomes the index of my radical, and then this becomes a power, or the exponent, for the variable. So this is the same as 12 cubic root of a squared. This one right here gets a little bit more complicated because this 4/5 is going to go to both of those. So the first thing that I'm going to do with this, and not all the problems are going to do this, but on this one is I'm kind of looking ahead here and I'm saying, all right, a 5th root is 64. Well, if I write that out as a prime factorization, I do not necessarily get a 5th root. So just real quick, I'm going to look at this prime factorization. Let's do that over to the side. Let me erase that. All right, so the prime factorization of 64 is going to be, let's see, let's do 4, 16, 2 and 2, 4 and 4, whoops, and 2, 2, 2, 2. So the prime factorization of 64 is 2 to the 6th power. Well, I'm trying to find a fifth root of that. 2 to the 6th power is going to be the same thing as 2 to the 5th times 2. So I'm going to pull out that fifth. Now, this is kind of complicated math, so just bear with me on this. We'll get through it. But I'm going to pull out that fifth, which 2 to the 5th is the same thing as 32. So I'm going to split this thing apart and say that this is 32 times 2a. And raise that whole thing to the 4/5. So I'm looking ahead here and trying to think, well, I'm going to need to find a fifth root of a number. 64 doesn't have a fifth root, but one of its factors does. So I'm going to pull that out, and this is kind of related to factoring, which we're going to be talking about later. Now, I distribute this to everything that's in here. So this is going to be the same thing as 32 to the 4/5 times 2a to the 4/5. So let's go ahead and deal with this. 32 to the 4/5. 32 to the 4/5 is, I'm going to rewrite my 32 as 2 to the 5th. And then I'm going to multiply it by 4/5. And I know that it's 2 to the 5th because of the prime factorization that I did over here. And then I'm going to multiply this whole thing by the 2a to the 4/5. 5 times 5/4 equals just the 4. So I'm going to get 2 to the 4th times, just leaving this 2a here to the 4/5. That's just riding along for now. And then go ahead and do 2 to the 4th, which is 16. And then I'm going to go ahead and change this whole thing. Because 2 does not have a fifth root, I'm just going to leave it with the a inside that parenthesis. The 5 will go here. I'm going to put 2a here to the 4th. Now I could go ahead and square the 2 or write the 4. 2 to the 4th, which is 16, and then the a as a to the 4th. But this is good enough right here. If there's nothing I could do with that in terms of the index, then I leave it. But here, if I can raise something to a fifth in there, I got to pull that out. Now that is a mess of a problem. So you want to make sure you have that copied down so that you could refer back to it. Here's a couple for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, here's what I got. This first one shouldn't have been too bad. That's pretty quick. This one right here, again, it gets messy. So I found the prime factorization. I found I'm looking for a cubic root at some point, and I find that I have a prime factor that's cubed within it. So I separate that out, and then I'm left with this 2y. When I get down here to the end, I have 2y squared. Now I could distribute that, or I'm okay with you leaving it this way as well. But it's such small numbers that it's probably better to go ahead and just get rid of those parentheses, so that you have 4y squared. But again, I would count either one of those as being fine. I know that's confusing. Hang in there, all right? This class is starting to get difficult, but you will spend a lot of time on this again in Algebra 2. So don't freak out on me. Just keep plugging away. All right, so converting to exponential form, it says, what are the expressions in exponential form? This is just going the other way. So this first one is going to be b to the 3/5. And for the second one, I'm going to rewrite it in exponential form first. So I'm going to take what's in here, the radicand, and I'm going to rewrite that in parentheses. And then instead of it being to the cubic root, I'm going to raise it to the 1/3. Now from there, this gets distributed to everything. So I'm going to have 27 to the 1/3 times d to the 5th to the 1/3. Now 27 is a cubic root, which is 3. And then here I just multiply 5 times 1/3, which is 5/3. So this one is not nearly as bad as what we dealt with on that last slide. So that's going to be 3d to the 5/3. Make sure you have that example copied down. Here's a couple for you to try. The answer will be up in 3, 2, 1. All right, so here's what I got. I got s to the 2/3. That should have been pretty simple. And then here is the other one, 4a squared. Not too bad, not like that other one that we were looking at a minute ago, but still a couple things that you got to make sure you're following. So if you didn't get this, go back and try to find your mistakes. I believe that's it today. Yes, it is. So hopefully you took good notes. I will see you in class.